Today we are going to discuss the questions of exercise 3.1 and 3.2 of the chapter 3, pair of linear equations in two variables. So starting with the very first question of the first exercise 3.1. So first question is, after tell his daughter 7 years ago, I was 7 times as old as you were then. Also 3 years now, I shall be 3 times as old as you will be. So isn't this interesting, representing the situation algebraically and graphically? So let Aftab's age be x years, let the daughter's age be y years. So 7 years ago, the Aftab's age was x minus 7 years, daughter's age was y minus 7 years. According to the question, so we have x minus 7 is equals to 7 times of y minus 7. Converting this equation into the standard form, we have x minus 7y is equals to minus 42. Then after 3 years, Aftab's age is equals to x plus 3 years, daughter's age equals to y plus 3 years. Again, according to the question, we have x plus 3 is equals to thrice of y plus 3. So converting in the standard form, we have x minus 3y is equals to 6. Now we have both the equations, and algebraically representation of the situation is 7x minus y is equals to 42 and 3x minus y is equals to minus 6. Now graphically, so it means in order to make it graph, so first we need to make the table. So in order to make the table, so first equation is x equals to 7y minus 42. So we have taken like this. So we have x of the value of y is equals to 5, then value of x is equals to 7, value of y is equals to 6, x is equals to 0, value of y is equals to 7, x is equals to 7. Then second equation is x is equals to 3y plus 6. So x is equals to 6, y is equals to 0, x is equals to 3, y is equals to minus 1, x equals to 0, y is equals to minus 2. Now representing both this both these tables in a equation, then they will form a line. So as we can see here, this is the first and the second line. This way we represent this linear pair of equations or pair of linear equations in two variables like two lines. Then if we move towards the next question, question number 2 is the cost of a cricket team. Sorry, the coach of a cricket team buys 3 bats and 6 balls for rupees 3900. Later she buys another bat and 2 more balls of same kind for rupees 1300. Represent this situation algebraically. So let the cost of one bat be rupees x, then the cost of one ball be rupees y. Then according to question, 3x plus 6y is equals to 3900, and according to the second condition, this is the first one, x plus 2y is equals to 1300. So now converting into the standard form, so they are not converted to standard form. So there is given 3x plus 6y is equals to 3900 and x plus 2y is equals to 1300. Now for the graphical representation, the 3 situations for each equations are as follows. Again, we'll draw the table. So if we see in the table, we have in the first equation x is equals to 3900 minus 6y over 3. So if x is equals to 300, y is equals to 500, x equals to 100, y is equals to 600, then x is equals to minus 100, y is equals to 700. Now from the equation 2, we get x equals to 1300 minus 2y. So we have x equals to 300, then y is equals to 500, x is equals to 100, y is equals to 600. If x is equals to minus 100, y is equals to 700. Now converting both the table, so in a form of a line, so what we are getting a single line for both the equation. So this is the required graphical solution. Okay, then moving towards the question number 3, if you see the question number 3, so in the question number 3 it is given that the cost of 2 kg of apples and 1 kg of grapes on a day was found to be rupees 160. After a month, the cost of 4 kg of apples and 2 kg of grapes is rupees 300. Represent the situation algebraically and geometrically. So let the cost of 1 kg of apple be rupees x, the cost of 1 kg of grapes is rupees y. According to the first condition, 2x plus y is equals to 160, and according to the second condition, 4x plus 2y is equals to 300. So hence the following is the algebraic representation of situation, that is 2x plus y is equals to 160, 4x plus 2y is equals to 300. Now for the graphical representation, there are 3 solutions for each of the equations. So now we have the table, we are writing the solution form of a table. So for the equation first, that is y is equals to 160 minus 2x. If x is equals to 50, then y is equals to 60. If x is equals to 60, then y is equals to 40. If x is equals to 70, then y is equals to 20. So from the equation 2, we get y is equals to 300 minus 4x whole upon 2. In this we are getting, if x equals to 70, then y is equals to 10. X equals to 80, then y is equals to minus 10. If x is equals to 75, then y is equals to 0. Now representing both the equations. So these are the equations of a line, so we are getting the parallel lines as we can see in the graph. Now we have the next exercise, exercise 3.2. that the question number 1 of this exercise is, from the pair of the linear equation the following problems, find their solutions graphically. So we have to find graphically. So 10 students of class 10 took part in a mathematics quiz. If the number of the girls is 4 more than the number of boys, find the number of boys and the girls who took part in the quiz. So if we see here, let the number of girls be x, then the number of and let the number of boys be y. So total number of students is equal to 10. So according to the question, we can write here x plus y is equal to 10. Also it is given that x is equal to y plus 4. That means the number of girls is 4 more than the number of boys. Now we have to represent the graphically, so we'll form the table. So if we form the table, now we can see in the table 1 when equation 1 x is equal to 10 minus y. So if x is equal to 5, y is equal to 5, x is equal to 4, y is equal to 6, x is equal to 6, y is equal to 4. Then from the second equation we can write x is equal to y plus 4. So here x is equal to 5, y is equal to 1, x is equal to 4, y is equal to 0, x is equal to 3, y is equal to minus 1. So if we see in this graph very carefully, so what kind of because these are the lines, equations of the line, so we are getting two lines here, and we can see that both the lines are intersecting each other. Okay, then if we see the second part, so in the second part the question is like this: 5 pencil and 7 pens together cost rupees 50, whereas 7 pencils and 5 pens together cost rupees 46. So find the cost of one pencil and that of one pen. Okay, so look here how to solve this. Okay, so we can see in the second part, let the cost of one pencil be rupees x, cost of one pen be rupees y. Then according to the first condition, 5x plus 7y is equal to 50. According to second condition, 7x plus 5y is equal to 46. Now representing in a form of a table, so we can see here that yes, in the first table when x is equal to 50 minus 7y whole upon 5, if x is equal to 3, y is equal to 5, x equals to 10, y is equal to 0, x equals to minus 4, y is equal to 10. And from the equation 2 we can write x is equal to 46 minus 5 y whole upon 7. If x equals to 8, y is equal to minus 2, x is equal to 3, y is equal to 5, x is equal to minus 2, y is equal to 12. So now when we are representing these equations in the graph, so we are getting two lines, again two lines are intersecting. So the point of intersection of both the lines is the solution, is the answer of the given question in part first as well as in part 2. Now moving towards the question number 2. In the question number 2, on comparing the ratio a1 over a2 comma b1 over b2 and c1 over c2, find out whether the lines representing the following pair of equations intersect at a point, are parallel or coincident. So if you look at the very first part, in the first part it is given 5x minus 4y plus 8 is equal to 0. Second part is 7x plus 6y minus 9 is equal to 0. So if we write a1 over a2 from here and b1 over b2 from here, then we can see here a1 over a2 is 5 upon 7, b1 over b2 is minus 4 upon 6, that can be written as minus 2 upon 3. Now we can clearly see that a1 upon a2 is not equal to b1 upon b2, so the given pair of linear equations intersect at a point. This is a condition of, yes, when both the lines are intersecting at a point. Then second part is this given that minus 9x plus 3y plus 12 is equal to 0, 18x plus 6y plus 24 is equal to 0. Now we are finding the ratios a1 over a2, which is 9 upon 18, that is 1 upon 2. b1 over b2, that equals to 3 upon 6, that is again 1 upon 2. Then c1 upon c2 is equal to 12 upon 24, that is again 1 upon 2. So we can easily see here that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So the following pair of linear equations are coincident, because according to the condition, so it is a, yes, coincident lines. So now looking at the third part, in the third part what we have here 6x minus 3y plus 10 is equal to 0, 2x minus y plus 9 is equal to 0. So we have here a1 upon a2 is equal to 6 upon 2, that is 1 upon 2, b1 over b2 is equal to minus 3 over minus 1, that is 3 over 1, and c1 upon c2 is equal to 10 upon 9. So a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, so it means the linear equations are parallel. Now moving towards the question number 3, so we can see in the question number 3, so in this question, on comparing the ratios a1 upon a2, b1 upon b2 and c1 upon c2, find out whether the following pair of linear equations are consistent or inconsistent. So we can see here the very first part, it is 3x plus 2y is equals to 5 and 2x minus 3y is equals to 7. So if you find the ratio, a1 upon a2 is coming 3 upon 2 and b1 over b2 is coming 2 over minus 3. So we can see here a1 upon a2 is not equals to b1 upon b2. So the pair of linear equations are consistent. Now when we say the term consistent means that the given equation have a solution, whether they have a unique solution or infinitely many solution. And inconsistent means when they have no solution, that is the lines are parallel. Okay, and in the consistent case the lines are intersecting or coincident lines. Now moving towards the second part, so it is given 2x minus 3y is equals to 8 and 4x minus 6y is equals to 9. So now again finding a1 over a2, b1 over b2. So if we see here, so in this question it is given a1 upon a2 is equals to 2 upon 4, that is 1 upon 2, b1 upon b2 is equals to minus 3 upon minus 6, that is 1 upon 2, and c1 upon c2 is equals to 8 upon 9. So we can see here a1 upon a2 is equals to b1 upon b2 but not equals to c1 upon c2. So the pair of linear equations are inconsistent because there is no solution. Then it is given 3 upon 2x plus 5 upon 3y is equals to 7 and 9x minus 10y is equals to 14. So we are adding a1 upon a2 is equals to 3 upon 2 whole upon 9, that is 1 upon 6. b1 upon b2 is equals to 5 upon 3 minus whole upon minus 10, that is minus 1 upon 6. So it is clearly given that a1 upon a2 is not equals to b1 upon b2. So the pair of linear equations are consistent. Now then we have the fourth part, 5x minus 3y is equals to 11 and minus 10x plus 6y is equals to minus 22. So we have a1 upon a2 is equals to 5 upon minus 10, that is minus 1 upon 2. b1 upon b2 is equals to minus 3 upon 6, that is minus 1 upon 2. And c1 upon c2 is equals to 11 upon minus 22, that is again minus 1 upon 2. So we have a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. So the pair of linear equations are consistent. Now we have the fifth part, 4 upon 3x plus 2y is equals to 8, 2x plus 3y is equals to 12. So a1 upon a2 is equals to 4 upon 3 whole upon 2 is equals to 2 upon 3, b1 upon b2 is equals to 2 upon 3, c1 upon c2 is equals to 8 upon 12, that is 2 upon 3. Now, so we can see here clearly that a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. So the linear pair of are consistent because these are infinitely many solutions. Now question number 4, which of the following pair of linear equations are consistent or inconsistent? If consistent, obtain the solution graphically. So looking at the very first part, it is given x plus y is equals to 5 and 2x plus 2y is equals to 10. So we will write here a1 upon a2 is equals to 1 upon 2, b1 upon b2 is equals to 1 upon 2, c1 upon c2 is equals to 5 upon 12, that is again 1 upon 2. So since we have a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2, so the pair of linear equations are consistent. So for consistent, so it will have to draw the graph. So for the first equation, the table is if x is equals to 4, y is equals to 1, x is equals to 3, then y is equals to 2. If x is equals to 2, then y is equals to 3. So from the equation 2, we get x is equals to 10 minus 2y whole upon 2, which, so in this we got the table x is equals to 4, then y is equals to 1. If x is equals to 3, then y is equals to 2, x is equals to 2, then y is equals to 3. So we are getting a coincident line. Now moving towards the second part. So now we see in the second part. So it is given x minus y is equals to 8, 3x minus 3y is equals to 16. So we have a1 upon a2 is equals to 1 upon 3, b1 upon b2 is equals to minus 1 upon 3, which is again 1 upon 3, and c1 upon c2 is equals to 8 upon 16, which is again 1 upon 2. So we can see here clearly that a1 upon a2 is equals to b1 upon b2 is not equals to c1 upon c2. So the pair of linear equations are inconsistent. Okay, so we are not forming the graph. Then the third part is 2x plus y minus 6 is equals to 0, 4x minus 2y minus 4 is equals to 0. So we have a1 upon a2 is equals to 2 upon 4, that is 1 upon 2, b1 upon b2 is equals to 1 upon minus 2. So we have a1 upon a2 is not equals to b1 upon b2. So the pair of linear equations are consistent. In this is a unique solution. Now we'll make the table for the first equation. X is equals to 6 minus y whole upon 2. So x is equals to 0, y is equals to 6, x equals to 1, y is equals to 4, and x is equals to 2, y is equals to 2. So from the equation 2 we have x is equals to 4 plus 2y whole upon 4. If x is equals to 1, y is equals to 0, x is equals to 2, y is equals to 2, x is equals to 3, y is equals to 4. So if we see the graph of this, so we are getting the intersecting lines, and we can easily find the solution also. The point of intersection is the solution, like here 2, 2. Then moving towards the fourth part. In the fourth part we can see It is given that 2x minus 2y minus 2 is equals to 0, 4x minus 4y minus 5 is equals to 0. So a1 upon a2 is equals to 2 upon 4, that is 1 upon 2, and b1 upon b2 is equals to minus 2 upon 4, that is again 1 upon 2, and c1 upon c2 is equals to minus 2 upon minus 5, that is 2 upon 5. So we can clearly see here a1 upon a2 is equals to b1 upon b2, but is not equals to c1 upon c2. So the pair of equations are inconsistent. So there is no need to draw the graph for this. Now question number 5. Half the perimeter of a rectangular garden whose length is 4 meter more than its width is 36 meter. Find the dimensions of the garden. So let the breadth of the garden be x and the length be y meters. So half the perimeter means half of twice of x plus y is equals to 36. This is the equation according to the question. So we have x plus y is equals to 36. Then it is also given that the length is 4 meter more than its width, so y is equals to x plus 4. So now we can see here, so we are finding the graph. So for graph we need to draw the table. So for the first equation, the table is x is equals to 3 and 36 minus y. So if x is equals to 0, y is equals to 36, x equals to 36, y is equals to 0, x is equals to 16, y is equals to 20. For the equation 2, x is y is equals to x plus 4, we have x equals to 0, y is equals to 4, x is equals to 8, y is equals to 8, x is equals to 12, y is equals to 16. So both the line intersect at 16, 20. So the breadth of the garden is 16 meter and the length is 20 meters. So I've just see the graph, what we are getting an intersecting line. Moving towards the question number 6. Given the linear equation 2x plus 3y minus 8 is equals to 0, write another linear equation in two variables such that the geometrical representation of the pair of so formed is intersecting line, parallel lines, or coincident line. So 2x plus 3y minus 8 is equals to 0. So condition we know a1 upon a2 is not equals to b1 upon b2. So we can write here x minus 3y minus 10 is equals to 0, or any other equation we can write satisfying this condition, that is a1 upon a2 is not equals to b1 upon b2. Likewise for parallel lines, the condition should be a1 upon a2 is equals to b1 upon b2 is not equals to c1 upon c2. So accordingly this equation we can write by ourselves. So here we have written 2x plus 3y minus 8 is equals to 0. So we have written 4x minus 6y minus 9 is equals to 0. Then for the third part, coincident line means we should have the condition a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. So equation is given 2x plus 3y minus 8 is equals to 0. So multiply the whole equation by 2. So you will get 4x plus 6y minus 16 is equals to 0. So in this way we are getting the equation. Now moving towards the question number 7. Draw the graph of the equation x minus y plus 1 is equals to 0 and 3x plus 2y minus 12 is equals to 0. Determine the coordinates of the vertices of the triangle formed by these lines and the x-axis shade the triangular region. So we can see here carefully that the equations are given. So we'll draw the table for the equation 1, that is x is equals to y minus 1. So if x is equals to 0, we have y is equals to 1. If x is equals to 1, y is equals to 2. If x is equals to 2, y is equals to 3. So from the equation 2, we get x is equals to 12 minus 2y whole upon 3. So x is equals to 4, y is equals to 0. If x is equals to 2, y is equals to 3. If x is equals to 0, y is equals to 6. Now, so we'll draw the graph. So such graph we are getting. Now it is given that formed by these lines and the x-axis. So these lines. So this is the line and the x-axis. This is the x-axis. So this is the required triangle. So the coordinates of the vertices of triangle formed by these line x-axis are minus 1, 0, 4, 0 and 2, 3. Okay, so with this we come to the end of the solution of the exercise. Yes, second exercise. So thank you very much.